Okay. We are doing this problem. Okay. So we have a ice cream shop that has 21 flavors of ice cream available. So that means that's our total number of ice cream flavors. And we're trying to select a bowl with 4 scoops. That's going to be our subset. Now, the next question is very important, is to decide whether the problem cares or communicates that we care about the order of the same 4 scoops of ice cream. And it doesn't seem to care. There's nothing in the problem that says that you care about counting the reorders of the same 4 scoops. So once you pick a set of 4 scoops of ice cream, that's going to be the same type of ice cream, even if you place them in different order, because it's the bowl, right? Okay. All right, so that means since the order of those 4 scoops does not matter, that tells us that we're dealing with the combination count. We're picking 4 combinations of scoops out of 21. Okay, and so at this point you can manually compute the number of combinations by first figuring out the permutation. So if I care about the order of my 4 scoops, then I would find it like this. So 21 options for the first scoop, then 20, 19, 18 are all 4. But then since we don't actually care about the reorders of those 4 scoops, I'm going to divide out the factorial of 4. All right, what is okay? Divided by 4 factorial. So I get 5,985 4 combinations out of 21. Okay. Now, the next question says you also want to select toppings. So out of 6 available toppings, you're going to choose 4 toppings in addition to your 4 scoops of ice cream. And so how many different combinations of the scoops of ice cream as well as the 4 toppings that are available? So for that, so we already know that the scoops, we have 5,985 of those. But now we have to figure out the count of toppings. And so we're also choosing 4 toppings, but out of 6 available ones. And once again, it doesn't say anything, the problem doesn't imply that you care about counting the different reorders of those toppings. So therefore, it's a combination of toppings, 4 toppings out of 6. And then once we figure out the number of toppings, then we're going to use the FCP, fundamental counting principle, the multiplication principle right here, to multiply the 2 counts together to find the total number of the different combinations of combinations. Okay. To find this value, I would do 4 times 5. That's 6. 6 times 5 times 4 times 3 over 4 factorial. What is that? Now you can always use your calculator to just compute 6 combination, choose 4, that's 15. 15 topping selections are possible. And then we're going to multiply 15 by 5,985 to get this lovely number right here. Now, so notice the number 15 is not going to actually be in your answer option because your second answer wants you to find the combinations of combinations. All right, so let's check our work. What do I say here? Okay, so for the number of ice cream scoops, we had 5,955. And for the number of combinations of scoops and toppings, we had that number. Right.